Okay, next problem. If 4 coins are tossed simultaneously, then find the probability of getting at least 2 tails. Okay, so here 4 coins are tossed and they are saying at least 2 tails should be there. So what is the table for 4 coins? It is 4, 6, 4, 1. Okay, and always the first one is 1 head, second one is for 2 heads. Okay, this since it is tails, so it is either 1 head or 1 tail, isn't it? So this can be for tail also. 2 tails, then 3 tails and 4 tails. Next, they are saying at least 2 tails should be there. So at least 2 means 1 we cannot have. So this 2 tails we can have, 3 tails we can have and 4 tails. So all these 3 outcomes are unnecessary for us. So it is 6 plus 4 plus 1 is 11. So 11 are our required outcomes. These are our required outcomes. Okay. And what are the total outcomes? Total outcomes is nothing but 2 raised to n, where 2 is the faces and n is number of coins. Number of coins are how many? 4, isn't it? So 2 raised to 4 is nothing but 16. So therefore probability is required outcomes divided by total outcomes. So required is 11 and total is 16. So 11 by 16 is the answer. Okay. So option D is the answer. Now you might be thinking how we got this table, isn't it? How we got this table. Now for that we can prove it here only in the fifth problem. Anyway, see here, 4 heads, 4 tails from 4 coins. How can we get, sorry, 1 tail from 4 coins? How can we get in 4C one way, and 4C1 is nothing but equal to 4. Then 2 tails out of 4 coins. Okay, out of 4 coins. How can we get in 4C2 ways? And 4C2 value is what? 4 into 3 divided by 2. 2 1s are 2 2s are 2 3s are 6, and this 6 itself is here. Next, 3 tails out of 4 coins. How we can get in 4C3 ways? So 4C3 value is what? Nothing but 4C1, which is equal to 4, and this 4 itself is here. And last one, 4 tails out of 4 coins. How we can get in 4C4 ways, and 4C4 is nothing but equal to 1. So this 1 itself is here. So we got 4, 6, 4, 1. Okay, in this same way the remaining table also we can get. Okay, so this completes coins based problems. Now next we shall see dice based problems. Okay, so before seeing dice based problems, what are the outcomes when 1 dice is thrown and when 2 dice are thrown? Okay, when 1 dice and 2 dice. Okay, so first we will see and then we will solve the problem. Now total outcomes here also it is given by the same formula. Total outcomes is equal to the face raised to number. Okay, face raised to number. Now if we throw 1 dice, what are the number of outcomes we can get? Number of outcomes, if we throw 1 dice, okay, a dice will be having 6 faces, isn't it? 6 faces will be there, a dice. So what are the number of outcomes we can get? It can be either, when we throw we can get either 1 or 2 or 3, 4, 5 or 6. These only are the number of outcomes when we throw 1 dice, isn't it? So therefore using the formula, how can we get? I told you all total number of outcomes is equal to face. A dice has 6 faces, so 6 raised to number of dice. So number of dice is how much? 1 dice, isn't it? So 6 raised to 1 is equal to 6. So total outcomes are 6. Through formula also we got 6, and when we saw using logic also we got 6. Okay. Now Similarly, when two dice are thrown, okay, when two dice are thrown simultaneously, okay, what are the outcomes we can get? We can get 1 1 on both the dice, or we can get 1 on one dice, 2 on another dice, and we can get 1 on one dice, 3 on another dice. Like that we can get 1 on one dice, 6 on another. So same way it can go on getting until 6 on one dice, 1 on another, 6 on one dice, 2 on another, 6 on one dice, 3 on another, dash 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 till 6 on both the dices. Okay, so therefore totally how much will get? Number of faces are dice has 6, and number of dices are how many? 2. So 6 raised to 2, which is equal to 36. So totally all these outcomes are how many? 36 outcomes. Okay. So when one dice is thrown, the number of outcomes are 6, and when two dices are thrown, the number of total outcomes are 36. Okay. So this much you should remember. Now, when one dice is thrown, then find the probability of getting a multiple of 3. Okay. First we will solve basic method, then we will see the trick on how to solve dice based problems. The way we solved coins based problems, that table which I gave, similarly we will have a table for dice based problems also, and by that table we can solve any dice based problems within few seconds, hardly some 2-3 seconds. Okay. Next, when one dice is thrown, then find the probability of getting a multiple of 3, they are saying. Now, when one dice is thrown, what all are the probable outcomes? What all are the total outcomes what we will get? Total outcomes, we may get either 1, 2, 3, 4, 5 or 6, isn't it? But what is required outcome for us? Required is what? That it should be a multiple of 3. So from these numbers, which one is multiple of 3? 3 is a multiple of 3 and 6. So required outcomes are for us 3 and 6. So therefore probability is equal to required outcomes divided by total. So required are how many outcomes? 2, isn't it? 2 divided by total are how many? 6. So it is 1 by 3. So probability is 1 by 3. Option A is the answer. Since it is only one dice, we can solve it easily. But if there are many dices, it becomes solving using this logical method will be very difficult. So that time we have to use the short trick. So next problem, when one dice is thrown, then find the probability of getting a odd number. Okay, so first we know that when one dice is thrown, what all are the outcomes? We may get 1, 2, 3, 4, 5 or 6. Now for example, this is a dice, I throw this, so I can get 1, I may get 2 when I throw, I may get 3 when I throw, or I may get 4, isn't it? Or I may get 5, or I may get 6, isn't it? So what all other outcomes we may get when one dice is thrown? Either 1, 2, 3, 4, 5 or 6. But required is what for us? That when we throw, it should be an odd number, they are saying. So which all are the odd numbers here? 1, 3 and 5, isn't it? So therefore total outcomes are how many? Total outcomes are 6, and required outcomes are how many? 3, isn't it? Therefore probability is equal to required divided by total. Required is 3 divided by total is 6. So 3 1s are 3 2s are. So therefore 1 by 2 is the probability. When one dice is thrown, the probability of getting an odd number is 1 by 6. 1 by 2. That is option B. See, logically also you can think, when we are getting 6 outcomes, in those 6, 3 are odd and 3 are even numbers, isn't it? That means 50-50, 50% is odd and 50% is even. That is what we got here, isn't it? A probability of getting an odd number is half. Half is nothing but 50%, isn't it? 1 is 100%, isn't it? So half is if getting odd is half, then even also will be half, isn't it? So when we add both only we get 1, isn't it? And probability value is always equal to 1, we know that. Okay. So next problem. When 2 dice are thrown simultaneously, then find the probability that sum of the digits on both faces is 8. Okay. So they are saying when 2 dice are thrown simultaneously, okay, the sum of the digits on both faces should be 8. Okay. That is, if I throw 2 dice like this, whatever number comes on these dices, okay, when we add those, we should get 8 as the sum. So what all are the possibilities? So this problem first we will solve using basic method, and then I will show a short trick here. Okay. So basically, to get 8, what all are the possibilities? In first dice it should be 3 and second dice 5, or first dice 5, second dice 3, or first dice 2, second dice 6, first dice 6, second dice 2, or in both dices 4, 4. Okay, so these are the 5, and can we get any other possibility? No, isn't it? Only these are the 5 possibilities. So 5 are the required outcomes, isn't it? 5 are our required outcomes. And total number of outcomes are how many? Total are how many? 6 raised to the number of dices. Number of dices are 2, isn't it? So 6 raised to 2, which is equal to 36. Therefore, probability is equal to required by total. Required is 5 by 36. Option A is the answer. Now let us see a shortcut for how to solve this. Now since it was a simple problem, we could find out the sum, isn't it? But if there are more dices and if it is more some number is asked more, then it will be difficult. So there is one short trick for this. So how to solve? Now probable sum, okay, probable sum and outcomes. Okay. Now see here, probable sum, what all we may get? We may get 2, we may get 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. 12 is the last sum we can get, because if on one dice if it is 6 here and another dice if it is 6 here, both when we add we will get 12, isn't it? Above than this can we get? No, isn't it? Because 6 is the last number we can get on the dices. Any number which is less than 6, it will be within 12 only. The sum when we add, it will be within 12 only. The maximum is 6 and maximum sum is 12. Okay. And how many times we will get 2? The sum of the probable of getting 2 sum is how much? If it is 1, 1 we will get 2, isn't it? Any other time we can get? No. And 6, how many probabilities we can get? When the both dices have 6. Any other probability is there? No, isn't it? That means 2 I can get only 1 times and 12 also I can get 1 time. Okay. So outcome is 1. Next, 3. If I want 3, what all are the probabilities? When on the first dice if it is 1 and second dice is 2, or second dice is 2 and first dice is 2, second dice is 1. Any other probability? No, isn't it? 3 and 1 will be more. 3 and 1, 3 and 4 will be more. So only 2 possibilities are there for getting 3 as the sum. Okay. Similarly for 11, first dice is 6, second dice is 5, or first dice is 5, second dice is 6. Any other probability can we get? When we add we should get 11? No, these are the only 2 probabilities. Okay. So therefore for 3 and 11, how many outcomes we may get? 2 outcomes. Similarly for 4 and 10 we will get 3 outcomes. For 5 and 9 we will get 4 outcomes. For 6 and 8 we will get 5 outcomes, and for 7 we will get 6 outcomes. Okay, if you remember this table, you can solve any dice problems. Okay, now let us check. If we want 9, how we will get 4 outcome? Okay, 9, how, what all if you add will get? 5 and 4, 4 and 5, 3 and 6, 6 and 3, isn't it? Any other thing we can get? No, because 6 only is last. 6 and 1 will not get, 6 and 2 will not get, isn't it? We want 9, isn't it? So these are the only 4 outcomes, isn't it? So 4 outcomes are there to get 9 as our sum. Okay, so this table 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so in this is one group. Okay, this is one group, that is first group, and this is second group. How to remember this I am telling. Okay, always remember, if the number is in first group, deduct 1 from that, and whatever number you will get, that will be the number of outcome. Now for example, to get sum 4, how many times how many are the outcomes? Okay, if I want sum as 4, so what you have to do, deduct 1 from this. 4 minus 1 is 3. So therefore 3 outcomes we will get to get sum 4. Similarly, if I want 7, if I want sum as 7, 7 minus 1 you do. In first group, any number minus 1 you should do. Okay, so 7 minus 1 will be 6. So 6, isn't it? We got here, isn't it? For 7 you will have 6 outcomes. Understood? Now for 2, for sum 2, how many outcomes you will have? Minus 1 in this, you will get 1. So for 2 you have 1 outcome, isn't it? So for first group, if any number lies in first group, deduct 1 from that, and whatever number you get, that will be the number of outcomes for that particular sum. Okay. Now if the number lies in the second group, okay, if the number lies in the second group, you should always see by adding how much. Okay, by adding how much it becomes 13. Okay, by adding how much number it becomes 13. If whatever number you add and becomes 13, that will be your outcome. For example, now see here, if for the sum to be 11, how many outcomes are there? Okay, so if you add how much for 11, you will get 13. If you add 2 for 11, you will get 13, isn't it? That means for 11, you will, to get sum 11, you will have 2 outcomes. Isn't it here? We got it? Isn't it? See here also, for 11, how many outcomes are there? 2 outcomes are there, isn't it? Now, for 10, okay, now if I want sum to be 10, how many outcomes are there? So for 10, how much if you add, it will be 13. For 10, if you add 3, it will become 13, isn't it? Therefore, for the sum to be 10, 3 outcomes are there. Okay, how is that? See here, 6 plus 4 is 10, 4 plus 6 is 10, and 5 plus 5. Any other outcome can you get other than these? No, isn't it? So only these 3 outcomes can give us 10 sum, isn't it? So therefore, to get sum as 10, 3 outcomes are there. How we got that? By adding 3 for 10, we will get 13. Similarly, for 8, okay, for if we want sum to be 8, by adding how much for 8, we will get 13. By adding 5, we will get 13, isn't it? Therefore, to get 8 sum, we will have 5 outcomes. Okay. So this is the simple trick. Just remember that if the number lies in first group, that is 2, 3, 4, 5, 6, 7, then deduct 1 from it, and that number will be the number of outcome. If the number lies in second group, that is 8, 9, 10, 11, 12, then see how much if you add, it will become 13, and whatever the number you add, no, that itself will be the number of outcomes. Okay, so this will be little bit confusing. Now if we solve problems, you will understand. So let us solve the problems. Okay, the same problem we can solve using this shortcut method. So first we will see, when two dice are thrown simultaneously, then find the probability that sum of the digits on both faces is 8. Okay, so our required outcome is what? We should get 8, isn't it? Now 8 lies in second group, isn't it? 8 lies in second group, right? See here. So in second group means how much if you add for 8, you will get 13. How much if you add? You should add 5, isn't it? Therefore 5 is the number of outcomes for the sum 8. So therefore required outcomes are 5. Okay, required outcomes are 5, and total outcomes are how many? Total we know how to find out, isn't it? 6 raised to the number of dices, 6 raised to 2, which is equal to 36. Therefore probability is equal to required divided by total. Required is how much? 5, and total is 36. Same we got, isn't it? Same we got as this method. So this table method will be very useful to solve any difficult problems. So we'll see next problem. When two dice are thrown simultaneously, then find the probability that sum of the digits is a multiple of 4. Okay, the sum of the digits should be a multiple of 4. Multiple of 4. So what all are the multiples of sum of the digits is a multiple of 4, they are saying. Okay, so what all are the multiples of 4? Tell me. Multiples of 4 are 4, 8 and 12. Any other number is multiple of 4? Because maximum when two dices are thrown, the maximum sum we can get is 12, isn't it? We cannot go beyond that, because 16 is there, next multiple. But is there any number on the dices when we add will get 16? No, isn't it? Maximum sum we can get is 12. Therefore maximum multiples we can get when the dices are thrown is 4, 8 and 12. Now 4 lies in the first group, isn't it? So at minus 1 we will get 3 outcomes. Then 8 lies in the second group, plus 5 you will get 13, isn't it? So 5 outcomes. And 12 lies in the second group, plus 1 will give you 13. So therefore total number of outcomes, how much we will get? 1. Therefore required outcomes are 3 plus 5 plus 1, which is equal to 9. Okay, then what are the total outcomes? Total outcomes is 6 raised to the number of dice is 2, which is equal to 36. Therefore probability is equal to required divided by total. Required is 9, divided by total is 36. 9 ones are 9 fours are, which is equal to 1 by 4 is the answer. Option D. Next, when two dice are thrown simultaneously, then find the probability that sum of the digits is a prime number and less than 8, they are saying. Okay, the sum of the digits should be a prime number and it should be less than 8. So which all are the prime numbers less than 8? Prime numbers less than 8 are which all? 2, 3, 5 and 7, isn't it? So these are the prime numbers which are less than 8, and the sum of the digits should be a prime number, means when two dices are thrown, their sum should be a prime number, they are saying. Okay, so if we want 2, then it should be 1 1 on both. If we want 3, it should be 1 on one and 2 on another, isn't it? Or 2 on one and 1 on another, isn't it? So how many outcomes like this we will get, they are asking. So therefore to get 2 as the sum, 2, 3, 5 and 7 all lie in first group, isn't it? So deduct 1 from them, you will get the number of outcomes. So to get sum as 2 2 minus 1, so 1 is the outcome, so again minus 1, 2 minus 1, 4 minus 1, 6. So therefore required outcomes are how many? 1 plus 2 plus 4 plus 6, which is equal to 13. Okay. Therefore probability is what? Required divided by total. Required is 13. Total outcomes are how many? 6 raised to 2, which is equal to 13 divided by 36. So option A is the answer. So these were dice based problems. Okay. Next we will see balls based problems.